Okay, so we've got this data here and we want to draw a scatter plot on Geogebra. The best place to start to type the data in is to go over, change perspectives, go to a spreadsheet perspective. Then we can type in our list of points here. So type in the data points with the x values in column A and the y values in column B. Check that you're typing your points in carefully.
Slash calculate.
So 1, 2, 3, 4, 5, 6, 7.
It doesn't have a 3.
8. Oh.
Get perspective. Okay, when you've typed your data points in, select them like this. Select your data points. Then here on these lists at the top, see on these lists at the top, you want to choose a list of coordinate points. So choose list of points. Choose list of points. It will give you an opportunity to name it. This is going to be called list 1, L1. That's okay. Now change perspectives back. Click on the perspectives button and go back to the graphing perspective. And we should see our coordinate points here. We can resize it. We can zoom out a little bit. Yeah. Does it go up to 22? Yeah. If I want to shrink just one axis, point to that axis, hold down the shift key, click and drag. It looks like this.
Sure. When we do the list of points, we just click OK.
Yeah.
Sure.
So how do you, I put them on spreadsheet, I'm just a bit confused, what happened now? Go back. What happened, what's going on? Oh, there we go.
So select the data.
Slide. It was the one that I wanted. So
we get all of the.
yeah. It wasn't that hard.
We don't
On
want
the list.
Yeah. I'm happy to
Change the perspective back to change the perspective. Go back to the graphing perspective. Okay. Type in your data. Okay, so let's have a go at Nila.
Yeah.
Let's have a go at answering some of the questions. So Nadia is walking home from school. Sometimes she is on her own and sometimes she's walking with one or more friends, so her pace varies. The table shows the data of her distance from home. So where did she start?
School. Or from home.
Where did she start? Did she start at school or did she start?
She
started at home.
0.5 distant from home.
She started at home and she went to school. How far is Nadia's school from home? When did she?
11.
11,
11 kilometers.
11,
11 feet wide times.
1.1 kilometers.
Why?
Really like this system.
Oh,
Yeah,
yeah,
1.1
times. Oh, yeah.
Read the units carefully. Read the units carefully. One value is 100 meters. So we have 1100 meters, 1.1 kilometers.
He has to walk.
So she is 1.1 kilometers. How long did it take her to get from home to school?
22 minutes.
22 minutes.
So the why do we have to change it to kilometers? So we can always keep in the unit that we're using. Like, why do we have to change it?
You don't have to. It doesn't say.
Yeah, it doesn't say.
It doesn't say, but you should always choose something that seems sensible. Okay, can we model this with a single function?
Yeah.
What type of function? Would it be right to model it with a
The distance she walks per like minute.
So if she starts off at home, I'm going to need a point at home. I'll put that in. If we want to model it, we could do a line like this to here, and we get a straight line. Would that be a suitable model to model this?
No.
Why not?
Because
Because the points aren't close enough to the line. It's not going to predict any value for us apart from the first and the last. So it's clearly not a suitable model. So how should we improve this?
Should we do the mean?
Could we use a piecewise function? Do you see two distinct domains here in this?
Yes.
Where does it change?
8 and 8. 8.
It's either at 6, 6 or 8, 8. It's hard to say which one of these two. If we use an 8, 8, that fits really nicely. This bit doesn't quite fit as well because they're all below. So we could use that. That's a good one. Or we could use this one, and there's plenty of reason to argue that one. But then again, the second bit doesn't fit so well.
Yeah, so then we have to change 3.
You could do 3 lines, or you could break it into a whole bunch of lines. So we're going to approximate it with 2.
Why can't we go one higher?
We will. So we're going to use this function. That's going to be the piecewise function. We want to find what the equations are for those graphs. Let me show you some tricks on how we can do that. So at the moment, I'm using the line segment tool because that's how it should look. This is how it should look. And just to neaten it up, I can press the move tool, and then I'll find the line segments in all your sort of gibberish here. Find your line segments, click on them, click on the settings, and just switch the labels off. I'll go to the other one. This one, switch the labels off. I'll go to the point M where we started, switch the labels. So you find the line segment or the intersect point I've made, you press the 3 dots, you get the settings, and then once the settings appear, there's a show label, and you can click that and it will switch them off. So it looks like this. What we want to do now is we want to find the equation for those 2 lines. So to find the equation of the line, we'll use the line tool instead of the segment tool. If I select the 2 points I used, it will draw me a line. Let me change the color of that. So this is a line. It's this one here at the top, line. Here on this one, change the settings. I can just change the color, make it red for now, so you see it. So this is the line. There's the equation of the line in general form. Notice the 3 dots here. If I choose the 3 dots and the settings, I can access the the algebra settings. And on this, it lets me in the drop-down menu choose which way to express the equation. We've got general form, and if you want mx plus b, it'll switch it to mx plus b. That's a nice function, isn't it? Y equals x. That's a nice function. Now, on the graph here, we don't want to see the whole line in both directions because we want a limited domain. So we've got the line segment, and then let's just switch that off so it won't show it, but we know the formula now. We'll do the same thing for this line. So this line here that I've just added is line I on mine. I'm going to change the settings, change the color so you see it. This is how the line looks. There we see it in general form. If I try to change this one over, I think this is probably best expressed in general form. If I change it to mx plus b, then it's approximated. It's rounding to two decimal places. So I'm not so keen on it rounding there. If we notice that we have it in general form, like this one, then I have an exact equation of the line. It's nicer numbers. Click on the red dot, it'll disappear, and there we have our model. So when it comes to the question here, how can we model it? Find a model to fit these data. So I'll just insert another page. What is that function? The function is f of x is equal to. Now, what's the first rule for the first segment?
The first what, sir?
The first rule.
8.
What's the first rule?
Y equals x.
Y equals x. What's the domain for that part of the function?
3?
What's the domain for this part of the function? Has to be an interval.
0 to 8.
0 to 8. Now, we're going to need to change this into
But I don't get it. So what's
mx plus b form. Robert.
Never mind. You change it.
Okay, so what's the second rule? What's the second piece of the rule for this part of the function? 0.214x plus 6.29.
Sir, mine is more round.
So how'd you get
Oh,
the?
the pencil, yeah.
What's the interval for this part of the function? What's the interval for this part of the function?
8 times.
It's going from 8 to 22. From 8 to 22. So this is 8. Which inequality symbol should we use here? Next to the 8. Less than. Why not less than or equal to? It will interfere with the other part of the rule. Caveat. So this gives us the function that describes the intervals we're working with.
I'm a bit confused how you got the calculation for the y value in the second part.
Okay, so to get the calculation for the rule part of it, so the first one was easy. It's y equals x. The second one is here.
Oh, it's there. Oh.
It's there. And I get that by drawing a line, not a line segment. When I draw a line, it will give me the rule for that line. So I get the rule here. The rule is given typically in general form, but we can get it specifically by changing the settings in the algebra to mx plus b form. And then you can switch the line off so your graph looks pretty.
Oh, okay. Thank you, sir.
Okay. here's our graph. Okay, so interpretation. When is she walking fastest?
Until from 0 to 8.
From 0 to 8, always specify a domain, x values.
Okay.
So she's walking fastest when in the first 8 minutes. Why do you think this is?
What has the most energy?
That's where it increases.
If she had the most energy, you would see her slowly slowing down, like a curve.
Maybe someone joined her for the other half.
Somebody's joined her at this point. You've got a real distinct change in behavior here at this point. And either maybe they bumped into a couple of friends and that has slowed them down. Also, you're going from home to school. How many people live at home with her? And then along the way, she's going to bump into people. How much of the group arrives at school?
Yes.
The whole group. The whole group. So it's far more likely, if you want to interpret why there's a change in speed, is that she bumped into some people and started talking with them, and then slows down her walking speed.
It's like saying that.
Yeah, a lot of questions on this course ask you to make interpretations. It's kind of in the title of the course. Applications and interpretations. That's what the I stands for. Okay, all right, let's stop there on the film.